welcome to this webinar on Cilium Mesh, Cilium multi-cloud networking. Today with us, we have Martynas and myself. We'll do an introduction to Cilium Mesh, what it is about. This is probably roughly 10 to 15 minutes. And then we will do a demo of Cilium Mesh, followed by an AMA where you can ask any question that you have on the project, on the product, on the further direction, and either Martynas or myself will answer. You can ask questions in the Q&A section or in the chat. With that, let's get started. This will be recorded, so if you have to drop earlier, don't worry, you can download the recording afterwards. All right, let's jump in. And for those of you who have never heard about Cilium, this may be actually the first kind of call or talk that you do on Cilium. Cilium is a CNCF project. It has originally been created by Isovalent, donated to the CNCF. It is eBPF-based networking, security, observability, as well as service mesh and ingress. So at this point, Cilium is an ecosystem of different projects. Most of you may have heard about Cilium from a CNI perspective or running Cilium as a CNI. Cilium is also available as a service mesh. There is an independent Hubble component, which provides network observability and monitoring, as well as Tetragon for runtime security and observability. Technology-wise, Cilium itself was written in Go. It uses eBPF as the primary technology for the data plane, and then some functionality that is not possible in eBPF, we leverage the Envoy proxy, for example, for HTTP processing. But let's jump into the topic of this call, of this introduction, Cilium Mesh. Cilium Mesh is the natural evolution of Cilium itself. And to many of you who have been using Cilium for a while, it probably comes very naturally. So initially, Cilium was exclusively focusing on providing Kubernetes networking. So networking for a single Kubernetes cluster, or back in the days, even Docker or Mesosphere networking. The first expansion beyond the scope of a single cluster was multi-cluster or cluster mesh. And we'll talk a little bit about this. This allowed to connect multiple Kubernetes clusters together across cloud providers or within a single cloud provider, or even hybrid cloud across on-premise and public cloud boundaries. Now, a lot of our customers have been asking, can you bring Cilium-based networking, intent-based networking? Can you bring the benefits of Cilium, the benefits of eBPF to the world outside of Kubernetes? How can I connect my existing workload to a Kubernetes clusters, or can I use Cilium-based networking simply to connect VMs and servers together? And with Cilium Mesh, we now have an answer. So Cilium Mesh is the combination of all existing Cilium components and the addition of one new component. So we have the existing components, the Kubernetes CNI, the ingress and the egress gateway, cluster mesh, the multi-cluster capability, the standalone load balancer, the egress gateway, the service mesh capability, and now new a transit gateway. In the picture on the right, you see an example on how this can look like. And this is really just an example. Of course, this shows an Azure cluster, an OpenShift cluster. Of course, you can run your Kubernetes clusters on any infrastructure. This could be GCP, AWS, on-prem, doesn't matter. And on the VM side or on the server side, we have an example on a set of EC2 instances and a VMware data center. But again, this could really be any sort of infrastructure. So with the Cilium Mesh, we're able to connect Kubernetes, VMs, servers across cloud, on-prem, and edge. Let's look a little bit on how this kind of evolved and what this is based on. The foundation, and as we dive into a bit more details, you will see that this is very similar and actually is based on the existing cluster mesh model. This is a short reminder on how cluster mesh looks like. Cluster mesh is the ability to mesh multiple Kubernetes clusters together. So you have independent Kubernetes clusters. They remain independent. There is no federation of any sort. They are independent Kubernetes clusters. And Cilium then builds a data plane below them, which gives you connectivity on different levels. You can have pod IP routing, You can do service discovery, you can do service routing, you can do encryption, you get observability on all the traffic, you can do identity-based security network policies, you can do load balancing, layer 3 to layer 7, and of course you can run the Cilium service mesh in a cluster mesh setup as well. This allowed to connect Kubernetes clusters together, and with the existing old or the traditional external workload with the existing traditional external workloads integration, which required running Cilium as an agent on the VM, you could essentially already include external workloads, on-prem clouds, and edge, and run that across all the public clouds, as well as on OpenShift and on-prem, of course. If you look at how this used to be configured and still is being configured, this is an example of a global service. So the ability to define a Kubernetes service that is then reachable across multiple clusters. So with YNN notation, it is possible to not only define that the service is global, but to also, for example, enable service affinity remote and always prefer remote endpoints. So not choose the local cluster endpoints, but to go to a remote endpoint. All of this is just one example of the cluster mesh configuration. All of these APIs is what we're now using to build cluster mesh. So the control plane of Cilium Mesh is entirely built on the existing well-proven cluster mesh control plane, which is highly scalable and has been battle tested in lots of different environments, lots of different setups. It is Kubernetes native and aligned. So these are all CRDs, which means that you can use Kubernetes RBAC, you can use Kubernetes audit, and so on. It is standardized. So we are aligning behind Kubernetes services, network policy, Kubernetes DNS, and all of this. And then they are extending that with Cilium CRDs to extend the basic capabilities of the Kubernetes standard itself. Then we have some new APIs that we are adding to add a multi-cloud routing ability, and we'll have a quick look at that. From an implementation perspective, this means that each site or each island, so if we go back to this picture, so each of these kind of blocks would be an island. So like Kubernetes cluster would be a site or an island. The transit gateway with the VMware environment would be a site. The transit gateway into the AWS environment would be a site. Each of them are represented as a Kubernetes cluster. If you're already running in a Kubernetes environment, of course, you have a cluster there. If you're running the transit gateway outside, Cilium itself will bring a Kubernetes control plane, a Kubernetes cluster, which will then participate in the cluster mesh. This is a giant benefit. It means that all the existing Cilium and Kubernetes tooling will just continue working as it has done before, and we're not rebuilding or reintroducing a completely new control plane. We can build on the experiences that we have gained so far. It also means that we can bring all of the observability tooling that we have. We have two examples here, the Hubble UI on the left with the service map, the flow view, as well as the Grafana plugin where we're seeing the node graph plugin in this case with a golden signal dashboard at the bottom. All of these toolings that have been available in a Kubernetes networking setting are now available on the Cilium Mesh outside of Kubernetes as well. And to finalize kind of this initial introduction, what does Cilium Mesh bring to multi-cloud and hybrid cloud networking? There's a lot of cloud native principles that come along that now enrich the world of multi-cloud and hybrid cloud networking. Of course, modern zero trust security principles, whether it's the aspect of distributed firewalling, so no longer using perimeter-based firewalls to do fully distributed microsegmentation, the transparent encryption, MTLS-based end-to-end authentication that is coming in 1.14, and so on. So it makes it trivial to bring these modern cloud-native principles and apply them outside of a Kubernetes environment as well. Of course, the existing SIEM integration to gain security observability will come along with as well. So all the nice benefits in terms of security principles that you have gotten used to from a Cilium perspective are becoming available outside. Then the deep end-to-end observability aspect. So Cilium via Hubble has very deep observability. All of that is becoming possible outside of Kubernetes. And then, of course, the multi-cloud aligned angle. Cilium has been selected by all major cloud providers in at least one of the managed Kubernetes offerings they have. So that's GKE, Anthos, EKS-A, and Azure or AKS. So we have super nice alignment with all the cloud providers because they're contributing to Cilium and they are directly aligning use of Cilium with their own SDN. At the same time, Cilium is completely independent and neutral, which makes it ideal as a multi-cloud standard. And then, of course, DevOps and GitOps alignment. All aspects of Cilium Mesh are optimized by using Kubernetes APIs. So whether it's CI/CD pipelines or GitOps principles, all the APIs can be fully automated. And then the highly scalable control plane, Cilium from the very beginning has been optimized to run in high scale environments, which means that the control plane we have built so far is ideally suited for high scale multi-cloud control planes as well. So if we're talking tens of thousands of nodes, that's not a surprise to us in the world of high scale clusters running container endpoints. That has been very common so far. As a next step, we would now do a demo, but I do see a couple of questions that have already popped up. So let me answer those real quick, and then we will hand over to Martynas for an initial demo. The first question, can the transit gateway be used to bring connectivity between clusters that run on the edge but aren't in the same VLAN or overlay network? Yes, you can. So we can talk in detail about this. In the end, what you will need to provide is some connectivity, some IP level connectivity between the transit gateways. It is even feasible that we could do this kind of connectivity via a additional hop in between. So even if you, for example, need to pass through a particular VPN between edge and core, not a problem. We could actually enable that as well. For example, laid out an infrastructure where we could build a multi-hub WireGuard mesh as the underlying foundation. So definitely happy to chat in detail about this. There is no assumption, an underlying assumption in the overall design that we need some form of specific overlay connectivity or VLAN connectivity. Even a connectivity across the public internet is completely feasible long term. And then I see that's the same question. Let's see any other questions that I haven't answered yet. I think that was it. So with that, Martynas, would you be ready to take us to the first demo?
Yeah, sure. Thanks, Thomas. And I'm super excited to show you guys what we built. So let me share my screen. And okie dokie. So okay, so before I do the demo, I just want to give you a brief overlook of the existing system architecture. So for the demo, I'll be using 3 different clusters. So as you can see, AWS cluster running Kubernetes, then GCP cluster running Google VMs, Google Engine-based VMs, and then on-prem cluster running bare metal servers. And what I'm going to show you first is basically a connectivity from on-prem client to the Nginx pod running in the AWS cluster, and also the connectivity from the GCP client to that Nginx pod, and also to the Nginx on-prem server. So let's start with the first one, and I'll be using Hubble to show all the flows. As Thomas mentioned, with this project, we have all the observability. Okay, so let's start. So the on-prem client is sending a request through the service to that Nginx pod. And if we open the Hubble UI, you can see that this client on-prem 2 is sending a request to the Nginx pod, and we can also see that it's running on-prem. The cluster is on-prem, and the pod is running on AWS. And basically, we have Hubble flow logs, so we can inspect each of them. And good thing is that we get all the security identities which you have with the regular Cilium installation. So we can do the identity-based network policy enforcement, which I will show you in a bit. And then if I jump to the client bad VM, which is running on GCP, and I send a request, and it doesn't work. So let's see what's happening. So I can see from the Hubble log that it's basically I have a policy which is denying the packet into the Nginx pod. So basically, as I mentioned before, we can apply network policies for different workloads, and a workload doesn't have to be just a pod. It can be any VM, Lambda, and so on. So basically, we can see that the policy is dropped. And let's do one more experiment. It's about sending a request from this bad VM to the Nginx on-prem. So basically, a request will go through the GCP transit gateway to the transit gateway instance on the on-prem, and then it will be redirected to the Nginx. And voila, we get a response from the Nginx on-prem server. And if you look into that, okay, it's a bit more now complicated view, but basically we can see that this client bed was able to send the request to the on-prem, and we can see this red arrow from the previous attempt. So yeah, let's take a bit a deeper look how it looks, and on the transit gateway node, from the transit gateway point of view. So we run Cilium in so-called transit gateway mode, and under the hood, we run also Kubernetes control plane, which gives us ability to use the existing, to reuse the existing APIs which we implemented in Cilium. So if I, let's say, jump to the on-prem server, I can actually use kubectl command to access some objects. So for instance, I can list the local workloads which are not pods, and for now we call them portals. And you can see that I have 2 workloads, and if you look in detail, you will see, for instance, that this Nginx workload has labels, and we can use those labels for the network policy enforcement, for creating services, and for other more advanced functionality. And the most interesting thing is also, the labels and the IP address of the workload. And basically, if you look into the service on that node, you will see that the Nginx on-prem service is using a label selector, which is selecting this Nginx server, which has been set in the Cilium portal endpoint. And then if I jump to the AWS cluster, which is running Kubernetes, I can actually list the network policy, and we can see that it's allowing only good clients to the Nginx pod, and it's label based, so no IPs are being used, and we derive the security identities from labels. So yeah, that was my demo, and happy to do a deeper dive if there are any questions regarding that. But just to recap, we demonstrated the connectivity between different clusters and between different workloads like pods, VMs, bare metal servers, and we showed that for this type of connections, we can apply the existing Cilium functionality, and we can also use the existing Cilium observability powers. So basically can use Hubble UI just to show the existing flows and to analyze the flows and so on. And finally, we as Thomas mentioned, we are building on top of the cluster mesh, and we basically get a lot of API for free, basically, and we can extend the API and we can reuse the existing API, which personally I find super neat, because you don't need to teach people who are familiar with Cilium completely different architecture or like completely different APIs. So it's basically easy to learn this new cluster mesh thing. Do we have
let's actually keep this slide open right now, because there was a question and this slide actually helps. So question was, transit gateway is like a daemon process running in the on-prem network. And this slide actually shows really well how the transit gateway will get deployed in the three different setups. So the easiest one is the one on the right. That's the one that existed so far, in which case Cilium is running natively on all the Kubernetes nodes. In this case, it is a daemon set or an agent running on all Kubernetes worker nodes. And then what is new is essentially the transit gateway deployment mode. And we have one example at the top. This is representing transit gateway running on an on-prem physical server. So think about this, that Cilium is essentially providing or acting as a physical router. So this would be a on-prem physical server where you plug in a network cable and you run Cilium as a transit gateway on it. This can be any Linux machine with adequate network hardware. And on the lower left, we have the GCP setup where Cilium is running as a transit gateway on a VM. So you're essentially nominating one or more. Ideally, in a production setting, you will nominate multiple VMs to be gateways in a highly available fashion, and it will reprogram the VPC routing to attract the traffic. So you're not running anything on the VMs themselves. You're essentially running Cilium as a router or as a gateway on VMs deployed into that VPC. And the transit gateway will reconfigure the VPC routing tables for traffic from those VMs to be sent to the Cilium transit gateway. Hopefully that answers the question on how the transit gateway or how Cilium Mesh is actually deployed. So the net new deployment model is the transit gateway where we are not running Cilium on the nodes themselves. So the VMs and servers, they can remain unmodified, but we are deploying Cilium as a router or transit gateway onto machines, either physical or virtualized, to participate in existing networks. And with that, we are opening up for questions. So we are essentially opening up the AMA officially. If you have any sort of questions, or if you would like to dive deeper into particular aspects, if you would want for Martynas to show some details, feel free to either raise it in the chat or in the Q&A window, and we're happy to take as many questions as we have time. And while people are typing, I will give a couple of more pointers on how to learn more. So if you have been intrigued and want to learn more about Cilium Mesh, we are starting a private preview of this functionality. So if you're interested to test versions of this and you want to get your hands on, feel free to reach out to us afterwards. You will all receive an email that you can actually just send a email response to, and you can sign up for a private review. Of course, as we develop this feature forward and as this goes further, we will also use all the existing channels in terms of blog posts, webinars, and so on to keep you up to date on how this actually evolves further. I see one more question. Martynas, can you talk a little bit about how the multi-cloud routing will look like, service, like exposure via service compared to routing prefixes? Will both be supported? Right now you have demonstrated the service construct. Will we also support the prefix-based routing?
Yeah, that's a very good question. So in my demo, I've been using so-called Kubernetes cluster virtual IPs. So it's basically, I can show you in the terminal. So when I was doing the access, for instance, from the on-prem cluster, I was using this IP address. And if you take a closer look into this on-prem server and you list all the existing services, you will see that basically I'm using this IP address of this particular Nginx service, and this IP address is cluster IP address. So basically, we are reusing existing load balancing mechanisms which we built in Cilium. But another access pattern is to use directly to use the IPs of the workloads in the different clusters. Just that for this particular access case, that there should be one requirement is that there should be no overlap between subnets. So basically, here we have this client on-prem 192.168.102 IP address, and it should be able to send a request directly to this Nginx pod, which is in a completely different subnet. So, but if there is an overlap in the subnets, then the Kubernetes service abstraction needs to be used. So basically, we need to use virtual IPs to access that particular workload. But yeah, we have two modes for accessing, and I think both can come handy, because with the service abstraction, you get the load balancing for free, because you can have multiple actually workloads which belong to the same cluster, and they can be which belong to the same service, but they can run on completely different clusters. So for instance, if you want to load balance in a HA manner, then you can use the service abstraction. So yeah, so just to recap, two different access patterns to accommodate all use cases.
We have another question that just came in. High availability. Can the transit gateway be made highly available? Can a secondary backup gateway be set up? What happens if the primary gateway goes down?
So we are currently working on the HA, so high availability of transit gateways. And the solutions differ a bit. Like if you deploy on-prem, we have the solution based on BGP announcements. So basically, you can have multiple active gateways, and then you, for instance, use ECMP to route the traffic to those gateways. So you can spread the load, and if one gateway goes down, then yeah, basically you can pick another gateway. So, and for cloud environments, we're also working on a solution, and I think we also have we are close to having this HA solution also for cloud environments, so that you could be able to have multiple active gateways. And if one goes down, then you basically use another gateway.
So basically, we'll have two modes. One is the HA mode, active, but then also an active passive or active backup mode, where we would actually reconfigure the routing table to go to a secondary backup transit gateway.
Yeah.
Excellent. And then the next question is on the security model. Can you show how we mapped the external workload, like the on-prem workload or the GCP workload, the VM, to a Cilium identity? Can you show that in the terminal, how that looks like?
Yeah. Okay, cool. So, okay, let's clear the window again, just to make sure that I'm in the on-prem cluster. So one thing which we have created and which creation will be automated is so-called Cilium portal endpoint. And we have two portal endpoints, so for each workload. So in on-prem case, it's for each individual server. And if I, for instance, list this Nginx on-prem workload, you see it's basically, okay, CRD, Kubernetes CRD, and a few important things are the following. So first of all, labels, so that we can reuse the existing functionality. And that also, for instance, we can apply network policies based on labels, and then the workload IP inside the cluster. It's in this case, it's a private IP. It's not reachable from outside. So yeah, and same goes for other workloads. And then under the hood, it gets propagated to a Cilium endpoint, and with this, you can apply even more functionality. So basically, yeah, for each workload, you need a representation. And with that representation, the representation is this Cilium portal endpoint. And with that representation, yeah, you can chain the existing functionality. So basically, like as I said, like network policy enforcement. And again, if you look into the network policy, for instance, on GCP, there should be a couple of egress policies, and we basically allow the client bad to on-prem Nginx or to client good egress. So basically, yeah, it's the same network policy. And I showed you before, I was setting the labels, and we can use those labels in the Cilium network policy. So yeah.
And maybe just to clarify or to extend this a bit, that we're showing the on-prem example, and in this case we have manually created the endpoint resource in this case. So we've manually mapped essentially the on-prem VM or on-prem server IP to particular metadata that we can then use in network policy. In a cloud environment, let's say an EC2 environment, we are working on an operator that will automatically create these endpoint resources, let's say for all EC2 instances matching certain labels. And we would query the metadata server, the AWS metadata API server, to query the EC2 labels and whatever tags that you have actually attached to the EC2 instances, essentially out of the box. So you would not need to manually create this for all the endpoints. We've simply, for the on-prem case, manually added this. As a follow-up question in this case, yeah, you wanted to add something, Martynas?
Just to add that on AWS, for instance, there are enough data points for each individual workload to derive the labels from. For instance, VM name, availability zone, which VPC it belongs, cluster name, and so on and so on. So.
Excellent. And as a follow-up question to one of the previous one, the architecture does not have to be in cloud or on-premise environment, but also edge IoT environment if the devices are running in the specific LAN. I can take that. Yes, so I think as long as essentially all we require is a Linux machine to run on, right? So essentially we have two ways of integrating external workloads of some sort into the Cilium Mesh. Option number one is what we have supported so far, which is to run Cilium as an agent on the device itself. So even on an IoT device, we could actually run Cilium, the agent, on that to connect that to the mesh directly. If it is not possible or not desirable to run Cilium as an agent on the device itself, we can put a router or a gateway in front. And in that case, we need any Linux capable machine to sit in front and act as the router. System requirements are relatively low, so we don't have doesn't need to be any sort of big machine. The size of the machine needed will depend on kind of the overall control plane size and how many machines that you're actually meshing together. And on that note, it may actually be worth calling out that the cluster mesh functionality is kind of obvious to everybody who has been running cluster mesh before, but it's maybe not obvious for people who are new to this. So cluster mesh is not requiring to build a full end-to-end mesh. You can build star-like topologies, and that's actually very common, that you do not want to mesh all the clusters together, but you may want to mesh different edge clusters with some centralized infrastructure, but you don't want to mesh the individual edge clusters together. And you can also mesh in a unidirectional way as well. You don't need to mesh bidirectional either. So there's a variety of different topologies that you can actually set up. All of that is already supported with the existing cluster mesh control plane. I hope that has answered your question, Tomoyo. Otherwise, please ask more in a maybe, if not, clarify the question further. Awesome. I just wrote me, yes, it does. And the last question I have for now is MTLS and Cilium Mesh. So we have MTLS-based authentication that is coming up in 1.14. Will this be compatible? Will this be available on Cilium Mesh? And if so, how would that look like? Do you want to take that question, Martynas, or should I take it?
I think you can take it. You have all the context.
Okay. So I think yes, the short answer is yes. So first of all, what is this MTLS-based authentication? We are bringing, so far we have been doing network policy enforcement purely on the network segmentation level, which means that we have network enforcement points at all the nodes. And if traffic was allowed, we would actually allow it. And if traffic was disallowed by the policy, we would disallow. But there was no additional authentication that happened so far. With the MTLS-based authentication, we are extending the existing network policy construct to not only allow to define what is allowed and what is not allowed, but to optionally on top require authentication for any traffic between two particular endpoints. So we could actually say, if you look at this picture, we could demand that if the client on-prem 2 talks to Nginx in the Kubernetes context, it not only needs to be allowed by the policy, they need to perform mutual authentication before the traffic is actually allowed. And this will be done by a MTLS handshake between the transit gateway that is running in the on-prem setting and the Kubernetes worker node that is running in the Kubernetes cluster. And the mutual TLS handshake, or the MTLS handshake, will use certificates, SPIFFE Spire-generated certs that will represent the client on-prem 2 and the security identity thereof, and the Nginx pod and the security identity thereof. And only if that mutual authentication is actually successful will the traffic be allowed. And then optionally, the traffic can also be encrypted in addition using the existing IPsec and WireGuard method. So the short answer is yes. And we're essentially making it possible to perform MTLS-based authentication, even for workloads, such as a VM or a physical server that you cannot modify, which means that the traffic from the VM and from the server to the gateway will still be not authenticated and potentially not encrypted, depending on how you run that infra. But all the path from the transit gateway, so as soon as Cilium owns the traffic, all of that path will be not only encrypted, but also mutually or protected by an MTLS handshake. I hope that answered that question as well. Let me see if we have additional questions. I missed anything? Just to confirm, for Nginx on-prem and client on-prem 2 will be out of scope for Cilium observability. Maybe you can talk about the observability and when we get that observability and how you use that in the demo.
Yeah, so the observability is being, like, all the flows are being observed at the transit gateways. And if you want basically to get the, let's say if the question was client on-prem 2 talks to the Nginx on-prem. So if it's using the same service abstraction to talk, and your infrastructure is basically configured in a way that all the service traffic goes through the transit gateway. So in this case, you would get the same observability because the client on-prem 2 will send the request first to the transit gateway, and that request will be forwarded to the Nginx on-prem. And because the transit gateway handles this request, it gets all the observability data points. And for the Kubernetes deployments, of course, easy because, like, to each pod in the Kubernetes cluster, we attach BPF programs which collect those flow information, like with all the metadata, like labels, security identities, and so on. And so this is easier, but in terms of the transit gateways, like those BPF programs are running inside the transit gateway. So every packet flows through the transit gateway. It's being collected and being converted in what you see in Hubble flows.
So essentially any traffic that traverses the machine where the transit gateway is running on, we will see the traffic. So in that sense, even though it doesn't seem intuitive, we could actually even reconfigure the routing table for the VPC or the BGP network and attract all the traffic of that network onto the transit gateway and use that not only as the router for endpoints that are in other sites, but even for the local site as well. So if this is something that would be demanded from you, or something that you want to implement, there's no technical limitation that would prevent you from using the transit gateway and Cilium running on it as a way to gain observability, even for traffic that stays within that VPC or inside of that network.
Just to add also network policy enforcement for east-west traffic, basically.
Yes, that's actually a very good point. So you could even you could ignore the entire multi-cloud aspect and essentially say, I only want to use this as a network level enforcement point for traffic in between VMs or servers in one particular site, and you want to do metadata-based network policy enforcement instead of IP address-based enforcement, or you want to run MTLS as well. And then we have another question that just came in. I want to use multiple OCE, OKE clusters connected via Cilium, CNI. Is this something Cilium is interested to support, similar to AKS, EKS, and GK? I'm assuming this means GKE. Is this just OpenShift? Is the question just OpenShift or some specific flavor? Let me see if I understand. Oh, this is Oracle. Is this Oracle Kubernetes engine? Yes. So technically we can already, yes. So technically you can fully run Cilium in Oracle Cloud Infrastructure if you run Kubernetes clusters there. We currently don't have a particular partnership agreement with Oracle, but if you are a customer of Oracle and you would like to explore this, we are happy to work with you to make that happen. We had some inbounds actually at KubeCon in Amsterdam from the Oracle team to make that happen, but there was not a particular customer that asked for this so far. So if this is of interest for you, reach out to us and we are happy to make it happen. Excellent. So yes, if you're a customer, feel free to reach out to me or just respond to the email afterwards, and we are happy to make the we are happy to make that happen. This is in general, I think as an overall statement, Cilium is capable of running on any Kubernetes distribution, and we have support partnership agreements with almost all the commercial Kubernetes distributions currently used. If you have particular requests on what is supported and where we have partnerships, feel free to reach out to us. And yes, Richard just said, thanks for the great demo. And he mentioned that Liz Rice gave a great demo at this KubeCon. Absolutely. So there is a similar demo of this that a recording is available for, which was given at KubeCon a couple of weeks back. So if you want to dive further, we'll actually include that in the follow-up email that goes out to all of you. Awesome. Last call for any questions left. I'll give it another minute. And in the meantime, if you want to have more information on this, if you want to dive further, again, there's a private preview. Feel free to reach out to us. If you have any further questions on Cilium itself, feel free to reach out to us at isovalent.com. You can also find a lot of information, including labs, tutorials, guides, screen recordings, demos at cilium.io as well. So that's a great learning. That's a great resource for learning. We also have Echo, which is hosted every week, which highlights a variety of different content in the Cilium and eBPF ecosystem.